Hi everybody, so this is A.R.S.E, so Random Sound Explains, and today we're going to talk about redshift and the age of the universe. So redshift is used to measure how old light is and how far away the light source is that emitted that light. And there's a correlation between the two. They can both be explained with the same value, which is light years. And like our sun, the light that it emits takes about 9 minutes to get here, a little bit less than 9 minutes, but it has a redshift value of 0 because it's so close to us. But like a star from billions of years away would appear to be red because of redshift, meaning that the light lengthened, and as it lengthens it gets more red, because the light spectrum goes from red to purple or white or whatever. So the age of the universe right now, 13.8 billion years, is if the Big Bang, we're going to concede that the Big Bang happened, so I want to quit saying if the Big Bang happened. So the Big Bang happened 13.8 billion years ago, and the age of the universe is 13.8 billion years. Observable universe in each direction is about 43 billion light years. So the observable universe is 96 billion light years across. Or it's 48. I'm sorry, 48 billion light years in each direction, with a distance of 96 billion light years across. So observable universe versus the size of the actual universe. With hyperinflation right after the Big Bang, the actual universe would be the size of Pluto, and the observable universe would be the size of a light bulb, with us in the center, looking in both directions. 96 billion light years across, 48 in each direction. But the actual size of the universe would be so much larger than that. Light, quantum dynamics of photons. Light's an airy source until you look at it, then it becomes that color. So when you look at a star that's far away, light collapses back to that source, across time instantly. So quantum entanglement right now is limited to pieces of an atom. We split an atom, and we know that quantum entanglement happens between those two pieces of that atom. What happens to one instantly happens to the other across time and distance. But light, it's collapsing to its source instantly, kind of can be explained in that way. The speed of dark, I guess, is what I call it. Because dark happens instantly versus the speed of light, which is observed at 186,000 miles per second. Yeah, so like I said, you look at a star that's far away, and that light collapses back to that source, across those billions of years, and it does it instantly, and that's a pretty wild aspect of photons and how they behave once they exit the quantum state into reality. So the age of the universe and the two different values of the cosmic background radiation right now, so like there's a 9% difference in dark matter versus dark energy, with the higher value being 70% dark energy and 18% dark matter, and the lower value being 68% dark energy and 27% dark matter. And like I've said before, this dark energy and dark matter is what's used to explain the unseen gravity that's observed in the universe. Because physics right now doesn't use gravity in any of its current physics models, because gravity just is, But I think that gravity, or the dark energy and dark matter, can be explained by phonon gravitational forces, because phonons spin and they create their own gravity, and I think that accounts for the unseen gravity. Phonons and photons operate independently of each other. So yeah, so the value given recently about the universe being 26 billion light years, or 26 billion years old, is because there's been some galaxies observed that are about 300 million years right after the Big Bang, which means that they're pretty old. So maybe the universe is older than we think. And So yeah, I mean it's possible. Um, like I said, I before if the Big Bang happened, because like I think that the universe has just always existed. You know what I'm saying? Like it just is, and like because yeah, I'll get into it in another video. But yeah, I think it's just always existed. But you know, if the Big Bang happened, the universe is about 13.8 billion years old. Um, but there has been some observations recently of some galaxies that might place the universe, the age of the universe, a little bit older than that. Um, so yeah, the cosmic background radiation temperature, 2.725 Kelvin, is one of the coldest known temperatures. Because it's the coldest in space. Because like the sun has something called the heliosphere, where that matter, even though space is cold, close to our sun, it's even colder the farther away you get. Um, yeah, so the age of light doesn't necessarily mean that the entire light theory is true, you know. Like after so many years, it just gets redder and redder. But I don't think it ever stops. Light moves at the speed it moves at. Even though the speed of light isn't a constant, it's affected by gravity, meaning that light can be slowed down by gravity, and it has been observed to be slowed down by gravity. It's still the maximum observable rate of light being the 186,000 miles per second. That, I guess, doesn't mean that light only moves at that speed, though. It can move faster because there's been black hole emissions that can only be moving faster than the speed of light, or something that's known as superluminous. And then, there's the light that goes into the black hole that is slowed down and trapped, or pulled into the black hole. And so yeah, like I said, even when we look at a far away light, we still have to take into account the intervening gravitational forces of the stars in between what we see far away and what's here on Earth. The intervening uh, effects of gravity on that light source. So yeah, redshift, it's a phenomenon that's true, but it doesn't mean that the entire light theory is true, or that we know the age of the universe. Like I said, the age of the universe is given from what we observe so far, the movement of some galaxies, and if we draw a line, like, oh, it was here, then it was here. How long ago was it there? That's how we figure out the age of the universe. Meaning, like, okay, that's what I mean. If you correlate 1 year and 1 second, right? After 1 minute of observation, you would have to look out your window and figure out where everything was 420 years ago. If the universe is 13.8 billion years old, if it's 26 billion years old, that 1 minute of observation you would have to account where everything was 825 years ago. So like I said in another video, when you go into this line of thought and research, you realize that we don't know what we don't know. But like I said, little by little we're figuring things out. And so yeah, redshift is true. Entire light theory isn't. And the age of the universe right now is being debated, but currently it's accepted at 13.8 billion years. Um, there's been some galaxies that are a lot older than they should be, meaning that they were formed about 300 million years after the Big Bang. So stars, I'll cover this real quick since I covered it before. There's two generations of stars. There's primordial stars, which happened right after the Big Bang, and then those stars, went through their life cycle. And then there's a second generation of stars that formed from that matter, which is what we see now, And yeah, so like I said, I guess that's it, for now. I'll cover photosynthesis in another video, because to me that's really interesting. But in the meantime, namaste, like, and subscribe, and see you guys next time.